Okay, welcome to my wonderful experiment here, trying to video myself explaining homework. Hello, everybody. Hope you will enjoy the show. Okay, all right. So these are the B and C level problems from the homework 11.1, and I'll just do an explanation of these. Problem number 18 gives you this figure here. And you need to find the area. So what I suggest you do is divide up something that looks complicated into regions that are easily calculated in terms of area. So, you know, I just drop this perpendicular here, drop this one here, drop this one here. So I label this region 1, region 2, region 3, region 4. And so basically, in order to find the area of the entire figure, I just add up the area of the individual regions. The area of the whole thing is area 1 plus 2 plus 3 plus 4. So this problem boils down to finding a whole bunch of little areas and adding them up. So region 1 is just a rectangle, so we know that the area for a rectangle is just base times height. So here's my base is 2, and my height is 2.8. I could have called 2.8 my base, and I could have called my height too, so it doesn't matter what order you get these in, for a grand total of 5.6 units squared, which I did not write. Bad me. Okay. Region 2, again, I have a rectangle. Now the problem is I need to find this dimension here. Now this dimension from here to here is 2. You know, imagine just kind of pushing this over here. And you can see that from here to here is 2. And remember, I've dropped the perpendicular, so these lines are parallel, so it's fine to do this. So this, from here to here is 2, from here to here is 2. So this entire dimension here is 4. Okay? So the base is 4 and the height is 2.8. 4 times 2.8. By the same token here, this dimension here is 4, this guy is 2, so this entire dimension here is 6. So again, we got a rectangle, base times height, 6 times 2.8 to get this area. And then this dimension here is 6, this is 2, for a grand total of 8. 8 times 2.8. Okay? And so this area, I add area 1, 5.6, to area 2, 11.2, to area 3, 16.8, to area 4, 22.8, for a grand total of 56. This time I wrote units squared. Good for me. All right. One thing I want to do, I guess, is try to focus this little sucker. So we'll see how this works. Nice. Okay. Fantastic. All right. Okay, good enough. All right, for problem number 20, what I have to do, I'm given this rectangle here, and I'm just given the diagonal as 18. This is the only information that I start with, that this is 18 and that this angle here is 30. So because I recognize that this is a right triangle here, I can figure out this other acute angle in my right triangle. If this guy is 30, then this one has to be 60, because I know that the acute angles in a right triangle are complementary. So interesting. Now I see that I have a 30, 60, 90 triangle. So I know the ratio of the sides. Opposite the 30 is a 1. Opposite the 60, radical 3. Opposite the 90 is 2. So, you know, I say 30, 60, 90. You say 1, radical 3, 2. And now I can see what the scale factor is. 18 to 2 equals 9 to 1. I can see that. It's the same scale factor, equals 9 radical 3 to radical 3. So I can see that this side length here is 9 radical 3, this side length here is 9. Once I have those, I know that the area is base times height, 9 radical 3, that's my base, times my height of 9, equals 81 radical 3 units squared. Good for me for remembering the units squared. Okay, next problem is 23. Okay. Again, you've got this funky little figure, and you need to divide it up into regions and calculate the regions individually. So I'm going to just, you know, continue this line here, continue this line here. It says in the problem that everything that looks like a right angle is. So, you know, region 1 is easy to see that it's a rectangle. So base 8y times height, 2x, for a grand total of area for this region, 16xy. Units squared, but I didn't write it. Okay, now the tricky part for region 2 here is I got to figure out this dimension. I know that this is 3y. I know that this is 3y. All together, I know this whole thing has to be the same as this because it's a rectangle and opposite sides are congruent. So I can see that this is 2y because 3y plus 2y plus 3y equals 8y. So this dimension here is 2y. This dimension here is 4x. And so when I multiply base 4x times height 2y, I'm going to get the grand total of area for region 2 is 8xy units squared. Now you'll notice that region 3 is exactly the same as region 1. So base 8y times height 2x equals 16xy. Okay, and again, let me just say, it doesn't matter what you call the base, what you call the height, but once you pick something, stick with it. Okay, so now the area of the total is the area of all three regions added together, 16y plus 8y, or 8xy, I'm saying it wrong, 16xy plus 8xy plus 16xy is 40xy units squared. Okay, good for me. I remembered units squared. Okay, moving on. This next problem is kind of an interesting one because we have to figure out, we're given just a diagonal of a square, and we have to figure out what the area of the square is. Now, I know that the area of any squared is side squared. So, just given a diagonal, I know that a square is a rhombus, and the diagonal bisects each of two angles. This angle is 90, so when it gets bisected, this is 45. This is also 45. So I have an isosceles right triangle here, 45, 45, 90. Another way I could have looked at this is, this is side length S, and this is side length S. So yes, I have an isosceles right triangle. I know when I have an isosceles right triangle that the sides are in the proportion 1, 1, radical 2. I say 45, 45, 90. You say 1, 1, radical 2. Okay, so now I can see I have to figure out the length of a side in terms of d. So scale factor, d over radical 2 equals side over 1. Okay, product of the means, radical 2 times s equals product of the extremes, d times 1, which is just d. Remember, I'm solving for the side in terms of d. So dividing both sides by radical 2, I get side is equal to d over radical 2, and then getting the rad out of the basement there, multiplying both top and bottom by radical 2 over radical 2, I get, well, you can see this, radical 2d and divided by 2. So there's my answer. So I know that the area of a square is side squared, radical 2d over 2. I got to square that whole thing. Now here's where a little algebra comes in. I have to square everything in the parentheses. So radical 2 squared is just 2, d squared is just d squared, and then 2 squared is 4. Okay, remember, everything in the parentheses has to get squared. Here's the rule. ab squared equals a squared times b squared. AB quantity squared equals a squared times b squared. So I apply that rule to this. Okay, then I've got the 2 here, I got the 4 here, they cancel, and I'm left with d squared over 2. So that's the area of a square given a diagonal of d. That's actually a nice little formula. Why don't you memorize this? Memorize this. Fancy little formula. Okay, 29a. This is kind of a fun little problem. You have a room and you have to figure out how much paint to buy, all right? So first thing you need to do is figure out the area of all the walls. You have a front, you have a back. I didn't draw in the back, make my picture too complicated. I have a side, I have another side. So the wall area is the front plus the back plus the two sides. Okay, I have to figure out the area of each of those regions, add them all together, and I'm good to go. Now the front is just a rectangle. They gave us the dimensions in the problem of 28 by 20 by 8. So base times height for the front, base 28 times height is 8. That gives me a grand total of 224 units squared. Mrs. Fredrickson, don't forget that. The back is the same as the front, so it's going to have the same area, 224 units squared. A side, base 20, height 8, 20 times 8, 160 units squared. So here I go. I add it. A front is 224, a back is 224, and I need two sides. So I need 2 times 160 for a grand total of 768 units squared. Now, each gallon of paint, it tells you in the problem, covers 300 square units of wall space. So let's do the division here to see how much paint I need. 768 divided by 300. That's about 2.56. Now, I can't go to the store and buy 2.56 gallons of paint. Too bad, but I can't. Osh only sells it in gallons. So what I have to do is just go to the next gallon up by 3 gallons. I'll have a little bit of leftover, but you know, after my kids draw on the walls with crayons, then I can paint over it. Okay, that's that problem. And then I have one more problem. This is a problem we did in class. I'll go over this one pretty fast. I have a rectangle. It's got a base and a height, and I have a square. And, you know, really, for me to be good, I should have put in all these little right angles so that we know we've got a rectangle here and a square here. So the area of the rectangle is base times height. The area of the square is side squared. Okay. The problem is they want you to construct a rectangle that has the same area. They want you to construct a square that has the same area of a rectangle. So first you construct the rectangle, and then you got to figure out, you know, what's the side length of a square. All right. So here's how we figure this out. I know these areas have to be the same, so I set base times height equal to side squared, and I solve for side. Okay. So you can see that when I take the square root of both sides here. All right, this is really the absolute value of S, but I'm only taking the positive value since we're talking about the side length of a square. So S is equal to the square root of base times height. So what does that mean? Well, that means suppose I have a rectangle with side or base 10 and height 4. What's going to be the length of a side of a square that's going to give me the same area as this? I know this area here of my rectangle is 40 units squared. All right, so according to my formula, the side length of my square is got to be the square root of base times height. So my base is 10, my height is 4. So the side length of my square is 2 radical 10. Is it true that the area of my square is 40? Well, we can check this out. 2 radical 10, quantity squared. This is going to be 4 times 10, which is 40 units squared. These two areas are the same. Whoop-de-doo. Okay, I'm done. I hope you enjoyed that. Bye-bye.